You ever open an app and it just works? It's smooth, it's flawless, it does exactly what you want it to do? Well, that magic is absolutely not an accident. Today, we're going to pull back the curtain on the invisible, unsung hero of our digital world, software testing. Let's get into why this is so important.
This right here, this is the core idea for this entire explainer. It's the simple truth that powers everything from your banking app to your favorite video game. Because without really tough, smart testing, even the most brilliant code is just a disaster waiting to happen. So what does that actually look like?
Okay, let me put it this way. Imagine you're getting ready for a huge bike ride, right? 100 miles maybe? You've got your helmet, your water bottle, but what is the absolute first, most critical thing you do before you even think about starting to pedal?
Exactly. You check the essentials. You make sure the tires have air, and you make darn sure the brakes are going to stop you when you need them to. Well, that simple, common-sense safety check, that right there is the heart and soul of software testing. It's all about kicking the tires before you send a product out into the real world.
So, that leads us perfectly into our first big question, the fundamental why. Why do these teams spend so much time, money, and energy trying to break the very things they just built? It really comes down to a couple of core principles.
So, the first thing you gotta understand is this. You can never, ever prove that software is 100% bug-free. It's impossible. Think of it like looking for typos in a huge book. If you find one, you've proved a typo exists. But if you don't find any, does that mean the book is perfect? Not at all. It just means you haven't found any yet. The whole game is to find as many as you can before your users do.
And here's where it really hits the wallet. Let's say you're building a house. If you find a mistake on the architect's blueprint, what's the fix? An eraser. It's cheap. It's easy. But what if you find that same mistake after the walls have already gone up? Whoa. Now that is a hugely expensive problem. It's the exact same with software. Back in 1999, NASA lost the $125 million Mars Climate Orbiter. Why? Because one team used metric units and another used imperial. A tiny bug that could have been caught in early testing literally caused a spaceship to burn up. A bug found early is cheap, a bug found late can be, well, astronomical. Okay, so we've covered the why. Now, let's get into the what. When we talk about testing, you can pretty much split it into two major categories. They ask two totally different but equally important questions.
So on one hand, you've got functional testing. This is super straightforward. Does the thing do what it's supposed to do? If you click the Add to Cart button, does the item actually end up in your cart? Simple. On the other hand, you've got non-functional testing. This is all about the quality of that experience. Sure, the button works, but is the process secure? Is it fast? Is it even easy for a new person to find that button in the first place?
Let's use an ATM to make this crystal clear. A functional test would ask, if I ask for $100, does the machine give me $100? It's a pass or fail, a yes or no. But a non-functional test asks things like, how long did I have to wait for my cash after I put in my PIN? Or what happens if 50 people try to use this machine in 1 hour? Does it crash? You see the difference? One is about what it does, the other is about how well it does it.
Now we're getting to the how. See, testing isn't just one big event. It's a whole process with different levels. The best way to think about it is like building a house. You don't just throw all the parts together and hope for the best. You build and you test, piece by piece from the ground up.
So, first up, you've got unit testing. This is where you're testing every single brick to make sure it's solid. In software, that means the smallest possible bit of code. Then you move on to integration testing. This is where you start putting those bricks together to build walls, and you check to see if they all fit together correctly. After that, system testing. This is where you test the entire house. Does the plumbing work with the electrical system? Is the roof on tight? And finally, and this is so important, user acceptance testing. This is when the new owner walks through the front door for the final inspection and says, yep, this is the house I wanted.
Okay, and that brings us to our final and maybe the most philosophical part of all this. At the end of the day, all of this testing, all these levels, they all boil down to answering two huge questions that really decide if a project is a success or a failure. Pay attention, because this difference is subtle, but it is everything. Verification asks, are we building the product right? Did we follow the blueprints? Did we build it according to all the technical specs? But validation asks a much bigger, much more important question. Are we building the right product? Did we even draw up the right blueprints to begin with? Is this the thing the user actually needs?
Here's the easiest way to remember it. Verification is like going through a checklist to make sure every single piece was put together correctly. Validation is about checking if you have a happy user at the end of the day. You could have a product that passes every single verification check, perfectly built, but if nobody wants it or needs it, it's a failure. True success only happens when you do both. You build the product right, and you've built the right product.
So the next time you fire up your favorite app, I want you to think about all this invisible architecture holding it all together. Think about the levels of testing and those two big questions that someone had to answer to make it all work. And maybe, just maybe, you'll start to see your digital world not just as a user, but with the curious eye of a tester, always wondering what little bugs might still be hiding right there in plain sight.